Welcome back. We can see this question is in the Cartesian plane, so what we will do is quickly draw the Cartesian plane. That's your y, that's your x, and that's the point P, 2, 5. And there's this, and there's the radius, which we don't know. Right, and that's your origin. Right. Now, first thing is we don't know the radius. We don't know the radius, so we have to calculate radius. So you'll say radius squared is equal to x squared plus y squared. X is 2, y is 5. X is 2, y is 5. So 2 squared plus 5 squared. Put that in your calculator, you'll get 4, 25, 29. So in your calculator, you'll get 29. So the radius is equal to square root of 29, and leave it like this because it's not a perfect square. This is not a perfect square. Or we're leaving it in third form. So another way we can say this is SURD, third form. So leave it in third form. Right, now we want sine. Sine POX is equal to y over r. Y is 5. Y is 5. We wrote down 5. And r we just calculated now. R is root 29. In fact, after you find the radius, it's always nice to write it in the diagram. So that's your sine. Then you want cos. Cos POX is equal to x over r. X is 2. X is 2 over square root 29. And then you want tan POX is equal to y over x. Y is 5, x is 2. Y is 5, x is 2. You could write this as 2.5. You could even write it as 2, 5. Just, you could write it like that. It's fine. Alright, so that was number 1. We hope you got that right. Now we'll move on to number 2. In number 2, we were given the point P minus 3. P was a point minus 3 minus 5. That was number 2. P was a point minus 3. So we draw our Cartesian plane once again. There's your x-axis, there's your y-axis. Minus 3 minus 5 will be in the third quadrant. So we just say minus 3 somewhere there, and minus 5 is somewhere there. So P is somewhere here. P is somewhere here. Minus 3 minus 5, that's x, that's y. And the angle this time is from there to there. Remember, in trig, we always move anti-clockwise for positive angles. So this is called a positive angle. We move anti-clockwise and it's a positive angle. Alright, so there's angle POX. POX. Now, we don't know what is the radius. We don't know what is r. So we have to calculate r. So r squared is equal to x squared plus y squared. And that will give you negative 3 squared plus negative 5 squared. Make sure you write it like that in brackets, otherwise you're going to get the wrong answer. And this will give you 9, and 25 will give you 34. R squared is 34. So R is equal to square root of 34, and we will leave it like that. We'll leave it in third form. We'll leave it there. So we found r. R is root 34. Right, now you want sine, cos and tan. Sine POX is equal to y over r. Y is negative 5. So be careful, don't forget about the sign. So it's negative 5 over root 34. Radius is root 34. Cos POX is equal to x over r. X is negative 3. Negative 3 over the radius root 34. And then you want tan POX is equal to y over x. That gives you negative 5 over negative 3. Negative 5 over negative 3, which becomes 5 over 3, because a negative divided by a negative gives you a positive. So it becomes 5 over 3. And this answer too could have been written as 1 and 2/3. Right. So we're purposely doing this. If you see that, it brings you to 1 and 2/3. That means one day if you see 1 and 2/3, you will bring it back. You will bring it back to 5 over 3. Right? And 1 and 2/3 can be 5 over 3, or it can be minus 5 over minus 3, depending on which quadrant we are in. So in this quadrant, both will be negative. Alright, that was number 2. We'll move on to number 3 shortly. Now let's see, number 3, what point we were given. In number 3, we were given the point 6, negative 4. We were given the point P is 6, negative 4. So once again, we draw our Cartesian plane. There's your x-axis, there's your y, there's your origin. 6, negative 4 is in the 4th quadrant. It's here, 6, negative 4. So 6 is perhaps somewhere there, negative 4 is somewhere there, and P is somewhere there, which is 6, negative 4. That's your x, that's your y. That's P. So the angle this time is a reflex angle going right from there to there. Right. Once again, we don't know what is R. So we have to calculate R. We got the x, we got the y, we don't know the r. So you will calculate r. R squared is equal to x squared plus y squared, which is equal to 6 squared plus negative 4 squared. That will give you 34 plus 16, 52. Put it in your calculator, please. Just put it in your calculator. So r squared is 52. So r is equal to square root of 52. Since it's not a perfect square, just leave it in the third form like that. Alright, so r is 52. And using different colors also helps you sometimes. So r is square root 52. Right. You want sine POX. So sine POX is equal to y over r. Y is equal to negative 4. Don't forget the negative sign. Negative 4 over root 52. And then you've got cos POX. Cos POX is equal to x over r. X is 6. R is root 52. And finally you want tan POX, which is y over x, which is equal to y over x, which is equal to y over x minus 4 over 6. And you're allowed to simplify this. It'll become minus 2 over 3. So that's your final answer for 10 POX, minus 4 over 6. And you can simplify that to minus 2/3. Alright, so that was the basics of trigonometry in the Cartesian plane. So from here onwards now, in our next exercise, you will be working either in a right angle triangle or in the Cartesian plane. So in our next exercise, we'll give you 2 or 3 examples, and one will be in a right angle triangle, the other one will be in the Cartesian plane, so that you practice both things. Alright, so you can sit back and relax till we give you the next exercise that will consolidate right angle triangle and Cartesian plane.